You are watching the 8.4 lesson video on solving real-life systems graphically. Now, in order to complete these questions, we have done a ton of translating in the past of word problems, but what is the most difficult thing to do with any type of, I would say, systems word question, as in probably any other word problem questions, is that you want to make sure that you know what the variables are, and you know that your equations are consistent with units. So if you have an equation that is only talking about monkeys, you want to make sure that every single term deals with monkeys. You wouldn't want like bananas to be one of the terms. Okay. So example number 1, Olympia High School is having a concert and 120 tickets were sold. Some were adult tickets and some were student tickets. The adult tickets cost $2 and student tickets cost $1. Olympia made $160 from the concert. How many adult and how many student tickets were sold? Okay, so the first thing that we should always do with a word problem is set it up. Give the reader or yourself some variables to work with. Now, within the question itself, they ask us how many adult and how many student tickets were sold. That's two things that we don't know. Another thing that you can really use to your advantage, sometimes it works, sometimes it doesn't, is you can look at the graph. Notice how they told you that X is the number of adult tickets and Y is the number of student tickets. So right up here in this question, I'm going to say that X is going to equal the number of student tickets. Actually, no, I think, okay, X is actually the number of adult tickets. And Y is the number of student tickets. Now that we know what our two variables are, anytime we bring in two variables means I either need to come up with two different equations or two different inequalities based on the context. So let's read into this question. There's numbers here that I haven't used yet, mainly money and tickets. So the one thing that I've noticed is that there is a $160 total that was made. And then we're also talking about adult tickets costing $2 and student tickets costing $1. It's all money. So I'm pretty sure that those values are all going to be the part of one equation. And let's label this. Total money. Okay, reading into it, it says the adult tickets cost $2. So that would mean 2 times my adult tickets, X. And with that, student tickets are $1, so 1Y. And they made, or the school made, $160. So if I add my student tickets, my Y value, and my adult tickets, my X value, of course with their actual ticket costs associated with them, I now have my equation. Notice how this term is in money, my second term is in money, and my third term is in money. Let's make sure that we're consistent with our second equation. So Olympia High School is having a concert and 120 tickets were sold. Some were adult and some were student. So we know that there's total tickets. And notice how I label my equations. I think that it's really helpful. We know that the total tickets has to equal 120, and that's the adult and student tickets combined. So you got it, X plus Y is equal to 120. Now, it doesn't always work out this way, that it's X plus Y equals some number. You always have to read into the question. Sometimes they might say, oh, there were 3 more tickets that were student tickets that were sold compared to adult, or something along those lines. So always read into the question to see what we should do with the equations. Now, if I want to graph these equations, it's not very easy to do right now because, well, I don't have it in y equals mx plus b format. But I think that we can do that pretty easily. It looks like I can subtract away 2x from both sides, or I could just move it to the other side. And I end up getting 1y, or just y, is equal to 160 minus 2x. Let's do the same thing with the total tickets. Here we get, well, we could subtract away x from both sides. And when I do that, I end up getting y is equal to 120 minus x. So if I would like to graph these, I can get some information from them. The first thing that I notice that my y-intercept is at 0, 160 of my first equation, or my total money equation, and the slope is negative 2 over 1. Let's do the same thing with our total tickets. That has a y-intercept of 0, 120, and the slope here is negative 1 over 1. If I look at my graph, my scale is not going to work for me. I think I only have 20 values here, and I have y-intercepts of 160. So let's see, maybe we need to count by, I don't know if we count by tens, will that work out? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I think it's pretty safe to scale every 10. So 10, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200. Perfect. And when I can, I like to keep my scales pretty consistent, so let's do the same for the number of adults, my x-axis. Now when I start to graph, remember that we want to go all the way up to 160. And the hard part about this is if I try to go down 2, I'm not really going down 2, I'm actually going down 20. So what I always like to do is scale. I'm going to multiply by a form of 1, 10 tenths, because my scale is 10. So this will give me a really nice slope to work with. So negative 20 over 10. So down 20 to the right 10. So down 20, so 10, 20 to the right 10. And we can do this to make sure the whole graph is covered. And we don't need to actually include arrows on the ends of this because we don't care about negative values. They don't make sense in the context of this problem. So here is my line. Notice how I also labeled it. Let's do the same thing with total tickets. And I'm noticing right away that my slope is negative 1 over 1, something I don't want to work with. So let's again multiply by whatever we're counting by, which is 10. So negative 10 over 10, or down 10 to the right 10. And it looks like here we're starting at 120. So down 10 to the right 10, and so on and so forth, until we've covered our entire graph. So here we have it. Notice how we used a straight edge and we labeled. Now, we also need to make sure that we answer the question. So it says up top how many adult and how many student tickets were sold. Oftentimes, people really just like stating the point of intersection, which is right here. So a lot of times people would just say 2 or 10, 20, 30, 40, and then 10, 20, 30, 40, 80. And they call it a day, and they say that that point is their answer. And unfortunately, what ends up happening is you will lose points for that because you're not stating the actual value of, like, you're not answering the question. So what does the 40 represent? Well, the 40 is my X, so that would be 40 adult tickets. And the Y is 80 student tickets. And this is your final answer. So don't just list it as a coordinate. Make sure that you always answer the question. And if it tells you to explain, you have to do that too. Heading over to question number 2, we can see that the local softball team is selling shirts and hats for a fundraiser. And the team needs to sell at least a total of 10 shirts and hats combined and needs to make a profit of more than 90. You know what, right away, I'm noticing that we are talking about at least a total of 10 shirts and hats. And then we're also talking about making a profit of more than 90. Gosh, those sound a lot like inequality words to me. Okay, reading on. Each shirt was sold for $3 and each hat was sold for $6. And the question is asking, will the team make a profit if they sell 15 shirts and 14 hats, and so on and so forth? So it looks like we have to answer a few questions at the end. I'm going to take a peek down at the bottom to see if there's any clues for me, and yes, there are. This is great. The number of shirts and the number of hats are my X and my Y. The reason why that is true is because we don't know how many shirts and how many hats are sold. So that could be another giveaway. If they didn't label it for you, we know that we're missing information. X is the number of, what was that? Shirts. And Y is equal to the number of hats. We also know that it's not going to be the value because they told us that in the question. Reading into the question a little bit further, it says the team needs to sell at least a total of 10 shirts and hats. Okay, so one of our inequalities has to be total, let's say total items. And we know that our total items have to be at least 10 combined. So that means more than or equal to 10. What has to be more than or equal to 10? Well, that would be shirts and hats. Notice how my units are consistent. So shirts, so number, number, number. Number of shirts, number of hats, number of items. Moving on to our second inequality. They need to make a profit of more than $90. So maybe we want to call this inequality the total profit. And we know that our total profit has to be more than, greater than $90. Well, a lot of times people want to say X plus Y is greater than 90. The only problem here is we have X being a number. So the number of shirts and the number of hats has to be bigger than $90. We have number, money. We're contradicting ourselves here. There's something wrong. So do we know how much a shirt is? Yes, we do. A shirt was sold for $3 and a hat was sold for $6. All right, next what I'd like for you to do is pause the video and solve your inequalities for Y so we can graph those easily. Okay, so here we have our two inequalities. Now let's start pulling some information from these inequalities. The first thing that I want to pull from is a starting point. So 10 is my y-intercept, and my slope is a -1, which is really -1 over 1. I also am dealing with an inequality, so are we going to shade above or below if it's a greater than sign? You're right, it would be above. And if it can be equal to, we will have a solid line. Let's do the same thing for our second inequality. Yep, our y-intercept is 15. Our slope is -1 over 2. We have a greater than symbol, so we're going to shade above. And it's not equal to, so we have a dashed line. All right, pause the video, and first let's graph our blue inequality. And actually, I probably should add before you pause the video, the scale looks great, so it doesn't look like we need to change our slope or scale at all for either of the two inequalities. All right, so here we have our blue inequality of x plus y is greater than or equal to 10. And notice how I shaded all above the line, and it was a solid line. Let me just double check. Yep, it was a solid line. So we are all set. Let's do the same exact thing for our purple line, or purple inequality. So here we have our purple inequality, or what was this, our total profit inequality. A couple things to point out here. Notice how at the end of my line I have an arrow because I don't have my y or my x-intercept appearing, so it's important to draw an arrow showing that this continues on in that direction. We didn't have to do that with our blue inequality because we're only looking at positive values. We don't care about negative hats or negative shirts. So we were able to see both the x and y intercept. Another thing, notice how I crisscrossed my shading. I always find that it's important to do this because it helps you to see where the shading should happen. And lastly, where the overlapping shading regions are, we are going to put a giant S, which represents the solution. Any single point in that crisscrossed area of shading in the solution is going to make the inequalities or the inequality system true. So I'm going to just kind of zoom, no, I want to zoom out so we can see if we're going to make profits from, I think I went a little too far. Here we go. So are they going to make a profit of 15 shirts and 14 hats? So namely, is the point 15, 14 a solution? Is the point 6, 20 a solution? And is the point 8, 14 a solution? So let's take a peek down below. So 15, 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is right here. So the answer is yes, it is a solution. It's in the shaded region. How about 620? All the way up to 20. It's that point right up there. And then 814. That would be here. They actually all happen to be solutions. And just because we didn't get an example or one that didn't work out, let's just come up with one on our own. So where one would not be a solution would be any point in this area down here where there's no shading at all, or even if it's just a point, like let's say here. So for example, 10 shirts and 2 hats. That would not be a solution. Okay, so 10 shirts, 2 hats. Another way that you could prove this algebraically is you could substitute in 10 and 2 into both inequalities, and you'll find that it would have to make both of them true. One of them or both of them might be false. In fact, the blue inequality would be true where the purple inequality would have been false if you substitute in the point 10, 2 into both.